So now we're going to talk about the Echelon matrix here. So in the Echelon matrix is the same as before what we are discussing, that we go on uh, eliminating the rows from A to U in the same way, but we may not able to get the pivots in the column next to each other. We may get the pivots by alternate columns, or after few columns we'll get the pivot. So that kind of matrix, so we'll get like a staircase kind of matrix. So that kind of matrix we call it as the Echelon matrix. So now, for example, if I take let's take an example here. So after forward elimination you will get some kind of a matrix like this. I'll write in a very general form, that is P represents the pivot and X represents some value. Do not get confused with the unknowns. These are some values. So here we have 7 columns. So 1 2 3 4 5 6 7, and so first row has the first coefficient, so it means it has the first pivot, and the second row, if the second value is not 0, then it has the pivot. So here it has the pivot, and then it has some values in that row. Whereas in the third row, the third element, the third component supposed to be the pivot, but if that value becomes 0, then there is no pivot in that third column. So likewise it will go in search of the fourth column. So fourth column, again, if the third component is 0, it means there is no pivot. So then it will go and search with the next column. So next column, third component is also 0, then there is no pivot. Then if in the next column, that is the sixth column, if there is any pivot value in the third component, if there is some value which is non-zero value, then that will be considered as the pivot. So likewise, and the next value can be anything here with respect to that. So next, supposed to be after this sixth column, then seventh column, fourth component supposed to be pivot. If that is 0, then what happens is entire fourth row will become 0. So now if you look into this matrix, you can substitute any number for X, that's not a problem. So if I draw this matrix, it looks like a staircase like this, a staircase representation with respect to the pivots. It is like this. So this kind of matrix we call it as the Echelon matrix. So now again I want to highlight the point that, so wherever we have the pivots, so we have the pivot here in the first column, we have pivot in the second column, and we have pivot in the sixth column. So these are my pivots. We will represent this as P with 3 pivot variables, and my free variables are column 3, 4, column 3, 4, 5 and 7. These are represented as F as free variables. So now how many solutions do we have? So we have, since we have the 4 free columns or 4 free variables, we will be having 4 special solutions for this matrix. This is the point which you have to remember it. Now the component has now every component every column has the 4 components. So therefore it is, what is the dimension it exists in? So since there are 4 components, then its dimension is 4, so it means it lies in the 4 dimension plane. That is another point. So here the null space n of u, which is represented as n of u, the null space is a subspace of R power 7. It means it's a subspace of 7 dimension. Now we'll write the procedure of this Echelon matrix. So we already seen in the previous tutorial. Anyway, we'll write it, the procedure for this Echelon matrix one by one. So the first one is that the columns, that is with respect to this example, that is 3, 4, 5 and 7 have no pivots. So the free variables are, the three variables are x3, x4, x5 and x7. And the second point is that now what we will do is that we will set one free variable with a value either 0 or 1. So here we will take, there are 4 free variables, so we will take each one of these every time and we will set it equal to 1 and we will try to find the special solution for it. So set one free variable to 1 and set the other free variables to 0. Then third step is solve ux equal to 0 for pivot variables x1, x2, x3. Sorry, we have pivot variables x1, x2 and x6. And fourth point is that this gives one of the 4 special solutions in the null space matrix N. So these are the points which you have to follow for the reduction of this null space. And also one of the other point that we have to remember here is that, so the above this 4 points defines the procedure. So here one important point is that the null space is subspace and its dimension is the number of free variables. So this is the point which you have to remember, that the null space is a subspace. Its dimension is the number of free variables. Its dimension is depends on the number of free variables. That is another way of looking into the number of dimensions. So now we will talk about the reduced row echelon form. So reduced row echelon form, already we have solved one of the example in the previous the previous session. So let me save this page. So page number 90. So then I will take this reduced row echelon matrix R. So reduced row echelon matrix R is nothing but we have a matrix A and we go with the forward elimination, we will get the upper triangular matrix. Now from the upper triangular matrix, what we will do is that we will divide each row by its pivots and then we will remove the values which are above the pivots by again the elimination method, with the upward elimination method. So that will give us the reduced echelon matrix form. So let us take an example and see that. So for example, we have a matrix here that is already it is in the upper triangular form. So now we'll take the same previous example that we had discussed. So that is 1 0 0 and then we have the next column that is 1 0 0 and 2 4 4 sorry 2 4 0. This is 3 4 0. So now if you look into this, so this is like in a form of the staircase, because if you see here, so we have this kind of staircase. It is not continuous, it is a kind of a staircase. So that is why it is called as echelon matrix. Why it is called reduced form, that we will see now. Reduced row. So to get the reduced row, now first thing is that what we will do is we will divide the pivot by that row by the pivot value. So the first row will unchanged because its first pivot is 1. So divide by 1 will give no effect. So now, whereas the second row will divide by 1, so I'll get it divide by 4, so I'll get this as 1. So next what we'll do is that we will remove these by upward elimination. To do that, what we do is that we'll subtract uh, row 1 from 2 times this new row 2. So then we'll get this reduced form. So or the final form, that is 1 0 sorry 1 1, there's no change. Now this is 2 and 2 get cancels here. Now this is 2, so I'll get 1 here. So this is 0 0 1 1 0 0 0 0. So this is called the reduced row echelon matrix. Now it has zeros above the pivots as well as the below. So let me write the definition here of reduced row echelon matrix. So what does it say is that the reduced row echelon matrix R has zeros above the pivot as well as below the pivot. So now my pivots are the first column and the third column. So now let us try to find the solution for this. So let me write this in a normal form. So let me write like x1. So what are the forms here? So I have this 1 0 0 plus x2 is nothing but it is again 1 0 0, then plus x4, sorry x3. What is the x3 I have here? That is 0 1 0 0 plus x4. I have 1 1 0. So as we all know that since there are two free variables, we will be having two special solutions for this null space. So what are the solutions? So let's find out. So now in the first case I'll consider that. So in the first case, so which are my pivots? The pivots is 1 and 3. Okay, so then I'll make my x2 is equal to 1 and x4 is equal to 0. So then what do we get here? Then I'll get my x1 equal to 1. So if you write this x1, I'll rewrite this quickly, plus my x3, that is 0 1 0, which is equal to, I'll get minus 1 0 0. So to get this, my x1 should be equal to minus 1 and x3 should be equal to 0. So when x3 is equal to 0, so I'll get this. Now what is my special solution, that is S1? So my special solution S1 is that is minus 1, then 1 0 and 0. So this is one of the solution. So the whatever the second solution, so second solution is that I'll make this x2 equal to 0 here, then my x4 is equal to 1. So when it is equal to 1, then what happens to my x1 and x3? So let's rewrite this. So x1 0 0, I'll quickly write this. So plus x3, so I'll get this as 0 1 0. Then this is equal, since x4 is 1, so what I get is that I'll get minus of, let me write it neatly, so minus of 1 1 and 0. So to get this, my x1 is should be equal to minus 1 and x3 should also be equal to minus 1. So my S2 solution is that so I should have minus 1 0 minus 1 0, then this is minus 1, and then x4 should be equal to 1. So this is my special solution. Now again, if you look into that, the null space, it's again the combination, the complete solution is the combination of these free variables and the solutions. So to see that, I need again space, which I don't have here. Let me save this page. It's not happened like before. Page 91. What will I do is that I'll remove this section which we don't want. So anyway, we have the solution. So what I will do is that I'll quickly remove this. So then our solution x, the complete solution is given by x is equal to x2 of, we'll write down the special solution, that is minus 1 1 0 0, and then this is same as before that we had discussed with one example before. Now this is minus 1 0 minus 1 1. Now the complete solution, if you see again, this is the combination of the free variables here, so that is nothing but minus x2 minus x4, and this is x2, this is minus x4, and this is x4, this is x4. So let us save as this. Page 92. So this is the complete solution. Therefore we can say that, let me write here, so then I can say this, the null space, n of a is equal to n of u is equal to n of r, all are same, contains all combinations of special solutions that we have shown above. Alright, so that's it for today's session. So hope you have understood this solution to the null space with the elimination method, and null space with the reduced row echelon form. Thank you.